Okay, so this is the third series and of the functional section that describes increasing, decreasing a constant function. So this is probably something that you've seen from your textbooks or from your professor in class, and it actually gives a formal definition on when a function is increasing, when a function is decreasing, and when a function is constant. I know that it may seem a little daunting for you to read this and try to understand it, but I always like to try to read math and draw math simultaneously. It always makes a little bit better sense to me. So now, since you have a fundamental understanding on graphically how to interpret where a function increases and decreases and where it's constant, this should be a little bit easier for you to understand in the long run. So let's go ahead and describe this first section here. So let's describe this first section in part one where we discuss an increasing function. So a function that is increasing. So increasing. So it says a function f is said to be increasing on an open interval I. And notice here it says open. And every time you see this, we're thinking open with a set of parentheses. So we're opening with a set of parentheses. That's just the definition. And that's why in the last couple videos I talked about why this function must be opening, use a set of parentheses, and we never ever use a set of brackets. And I'll explain that a little bit more in depth now, but it gives some open interval I, and I is just the interval. So in our last example, we had some intervals like 3 to 4, or -1 to 5, or 3 to infinity. Those are just intervals. So let's go ahead. I'm just going to draw a graph here and discuss what this means. So here it says that if there are values a and b, so there are values a and b in the open interval in that interval such that a is less than b. So I'm going to write a value a and a value of b. It doesn't matter where these values are. All I know that a must be less than b because it specifically says a is less than b. And I can clearly see no matter what I pick, if a was 3, b could be 6. 3 is definitely less than 6, so that's a check. If this was 5, b would have to be 7. Or 8, or 9, or 10. It doesn't matter. But as long as a is less than b, it suffices this definition. Implies then that f of a must be less than f of b. So let's go ahead and I'm just going to draw an increasing function. So I'm going to draw this increasing function, and if I come along and I examine this portion right here, this will give me a functional value at a. So this will be a functional value at a, and if I examine this over here, this will give me a functional value at b. And what do we notice about, and this is sort of not a good way to write this, so let me write this a little bit neater. So what do we notice about f of a in regards to f of b? So do we see how f of a and f of b have a relationship such that f of a is less than f of b? It's lower on the y-axis. So do you see here how f of a is less than f of b? And notice, in order for a function to be increasing, f of a must be less than f of b on that interval. So we see here that this is just a formal way of us describing where a function is increasing, and it does so using a almost ubiquitous sense. It describes every possible situation with an interval that could be increasing. So now let's go ahead and look at the second part right here in part 2, where it describes a function that is decreasing, a function that is decreasing. So a function is decreasing very similarly in definition, not actually maybe it's decreasing in form. However, it does have a different definition. So notice here it says that we have an open interval again, so that interval is open. We're thinking parentheses. And there's a value of a and b in there, and a must be less than b. So again, I have a value a and I have a value b, and a must be less than b, which is still consistently true. And let's go ahead now, since you know what a decreasing function looks like, let's go ahead. I'm just going to draw a steep decreasing function like such. It is going to be like such. So now if I were to go ahead and find these functional values over here, this could be my functional value at a, and over here would be my functional value at b. So I have my functional value at a and my functional value at b. Now, what can you all do, or how can we look at f of a and f of b? What relationship do we see between f of a and f of b? hopefully you recognize that f of a is above f of b on the y-axis, so that means that f of a is in fact always greater than f of b. And notice by definition, in order for a function to be decreasing, f of a must be greater than f of b. So probably now we'll go ahead and look at, so this was the decreasing function, this was the decreasing function, or decreasing interval of the function. Let's go ahead now, and I'm going to go draw a third graph down here, so hopefully it doesn't look too cluttered. But we'll draw a third graph down here. And notice here we still have the same portion of the definition. It says a function f is said to be constant. Function f is said to be constant on an open interval I. Again, you see that open term again. You're thinking parentheses. If for the values that exist in there, there's a value of a and b. And notice here, it doesn't say that a has to be less than b or a has to be greater than b. It just says if for all values in a and b, the interval, in that interval, f of a equals to f of b. So I'm just going to write, to be consistent, f of a and f of b, I'm sorry, a and b. And I'm going to draw a constant function. This is going to be a constant function. Hopefully we can see this is completely horizontal. And notice here, if I were to find these functional values, this would give me f of a, and this would give me, oh, notice there, the exact same thing. This would also be f of b. So f of b here equals to f of a. So f of a here equals to f of b, and that is how we describe formally a function that is constant.